Hello everyone. We are going to go through an AP question today. We're going to do 2004 Form B number 4, which is going to be your homework. That's going to build on what we did on my last video where we actually did talk about all the steps of how to create a two-sample t-interval for means. So, excuse me. So this question went over, it talks about that they were concerned with the number of hours of time that people spend on homework each night. It sounds like we have two groups, sixth grade students and seventh grade students. And notice they're listed here separately. I'm going to call population one sixth grade students at the school and population two seventh grade students. So they were interested in how much time they spent on their homework each night. Table below shows the mean and the standard deviation. So let's circle that mean and standard deviation of the amount of time spent on homework each night in minutes for the random sample of 26th grade and a separate random sample of 27th grade. So the first thing to note is we have two samples. It says they were random samples. The first one we'll call N1 for 6th grade, and the second one we'll call N2 for 7th grade. Now we have the mean and the standard deviation of the sample. So this is going to be X bar and S because these are statistics because they come from the sample. So I'm going to call this first one X bar 1 for the sixth grade students, and I'm going to call this S1 for the standard deviation of the sixth grade students, and X bar 2 and S2. So it says, based on the dot plots of the data, it is not unreasonable to assume the distribution is approximately normal. So they're actually addressing one of the assumptions we have to check, which is if the sample size is not large enough to use the central limit theorem, which 20 is not greater than 30, then we have to plot the data and look for approximate normality with no outliers or extreme skewness. So they're actually addressing it there in that little sentence down below. Estimate the difference in the mean spent on homework in this using an interval. Okay, so now the first thing to note is they did not give us the confidence level. Usually when they don't give us the confidence level, the standard that we use is a 95% level. So that's what I'm going to use. Notice I'm estimating the true difference between the means of the time spent on homework by all sixth graders and all seventh graders. So I'm going to use the sample means to estimate the true means. And that's the concept of a confidence interval. You're using your sample statistic, X bar, to estimate the population parameter mu. Similarly, we're using X bar 1 minus X bar 2 to estimate mu 1 minus mu 2, the true difference between the mean of all the students in the school and how much time they spent on homework, sixth grade versus seventh grade. So it looks like I put 1 for sixth and 2 for seventh. You could put 1 for seventh and 2 for sixth. It's up to you. They just really want you to define your parameters. So keep in mind if you use 1 and 2, you really have to define which one's 1 and which one's 2. Another idea would to be use 6 and 7, and then it's actually more logical which one represents which. Okay, so now please note it says we're doing an interval. Interval starts with the letter I, so remember the word that has an I in it is panic. So we're going to be doing the panic procedure. Step 1, P. P stands for state the population of interest and the parameter of interest. So population 1, I'm going to let be all sixth graders at this school. And I'm going to let population 2 be all seventh graders at the school. Okay, so now I'm just going to use those lines to kind of make my life a little easier. Parameter 1, let P1 be the true proportion. Oh, we're not doing proportions, just kidding. This is a mean question because notice we're using the word mean here. So remember with means, you're not using the word proportion. So we're going to let P1 for parameter. I'm glad I made that mistake. U1 be the true mean time spent on homework by all sixth graders at the school. And let's let mu2, because remember the mu is the parameter, be parameter 2 be the true mean time spent at the homework by the school for all seventh graders. Okay, so notice here the parameter is mean and not proportion. That's an easy error to make. So now we're done with P. And now we're going to move on to the A step. A stands for assumptions or conditions. The first assumption we have to check is that there are two independent, simple random samples. So it's stated in the question that they were random samples from randomly selected from the respective grades. So that's good. That means that we're going to assume it's a simple random sample from the grade. And then also we're going to assume that the two samples are independent of each other. That is pretty reasonable to assume. So we're done with that assumption. That's assumption one. Assumption two is 10 times n less than the population of interest. You're going to do this twice, okay? So I'm going to pause the video here and do it out for you and come back to you to save time. So as you can see, this assumption was met. And now let's move on to the last assumption, which is normality. It's stated in the question that when they plotted the data, that there was approximate normality with no extreme outliers or skewness. So even though the CLT was not met, the central limit theorem was not met because the two sample sizes were 20 each, because they stated in the question that normality was reasonable, that was great because now that assumption is checked. So now we have our three assumptions and we're able to proceed. So we did PA, N is next. N stands for the name of the procedure. So the name is two, there's two samples, sample, and then remember this is means. So for means we use T. If we don't have sigma, and we're going to use S in place of sigma. So this is called a two sample T interval for means. Okay? You can write for means if you want, and we're done with this step. The next is the interval step, I for interval. So we have NI. This is the one where you have to show the formula and symbols, then you do the number plug-in, and then you write your answer from the calculator, okay? So remember the formula is statistic plus or minus critical value times standard error of the statistic. When it was one mean, we would do x bar for our statistic plus or minus t star times the standard error of the mean, which if you remember is sigma over radical n or s over radical n. It's s over radical n when we're doing standard error, right? Because we don't have sigma. So similarly here, instead of one mean, this is a two mean question. So I'm just going to write it right underneath, and we're not actually going to use that one mean. I'm just showing you the structure is going to be the same. So it's going to be x bar 1 minus x bar 2 for our statistic. Plus or minus, critical value is still going to be t star. And then the standard error of the mean is going to be a lot longer of a formula than what it was over here. Okay, so I'm going to make a bigger space here. So now we're going to look up that formula on the reference sheet. So let's remind ourselves that we want to look for the means, not proportions. This is single sample and this is two sample. So we're going to look at two sample. And specifically, we're going to look here where it says standard error, and we're going to use this formula here. Instead of s over radical n, we're going to use s1 squared over n1 plus s2 squared over n2. So here we go. Plug that into that spot. Square root of s1 squared over n1 plus s2 squared over n2. Now we're going to plug in the numbers from the question. So x bar 1 was the sixth grade mean. The sixth grade mean was 27.3, and the seventh grade mean was 47. So we're going to do 27.3 minus 47. This is the number plug-in step, by the way. 27.3 minus 47. So that's actually the difference of the sample mean from that single sample. Okay. Now, t star. So here's where we have an option. We can either look at the smaller sample size, subtract 1. So the samples both were size 20. The 20 minus 1 would be the degrees of freedom, which is 19. And then you can look it up, the t star for that. But that's actually not going to be the exact degrees of freedom for this question. So what we're going to do is we're going to leave the t star blank for right now. We're just going to write t star, and we're going to come back to the interval when we run the procedure, and we're going to use the calculator for the exact t star. So we're going to just leave t star here. Now we're going to plug in the rest. S1 squared over N1. N1 was 20 plus S2 squared over N2. Okay, so we just have to look up the two standard deviations here and plug them in. S1 was 10.8 and 12.4. 10.8 and 12.4. All right, so now once you set this up, we put in our formula and symbols. I'm going to cross out the one mean so we don't get confused. We have our symbols, then we have our numbers, and now we could go to our calculator for our actual interval from the calculator. So what you want to do is you want to press stat, you're going to go over to test, and you want to choose a 2-sample t interval. 2-sample t interval is number 0 for me. Under 2-sample z interval, it's 0. And then you're going to either do data or stats. We don't have data in our list, so we're going to choose stats. And now we're going to plug in all the information we know. So x bar 1 was 27.3. S1 was 10.8. S2, N1 was 20. X bar 2 was 47. S2 was 12.4. And N2 was also 20, and we'll use a confidence level of 95. For this question, we never choose pooling for this. We only pool for the 2 proportion z-test. So we're just going to hit calculate, and then we're done. Now notice, look, we have an interval, but also we have the degrees of freedom. So now we can copy down the exact degrees of freedom for this question, and you notice that it's not 19. So 19 would have given us a different t-star, and it would have been a more conservative approach, and that's fine if you use that, but then you would have to actually calculate the interval by hand if you use the t-star corresponding to the degrees of freedom 19. So I actually prefer just leaving a t-star and then writing our interval from the calc and then writing the exact degrees of freedom from the calc. That way we are not rounding anything. So we're going to write 37.297 for our degrees of freedom, and that's the exact degrees of freedom. And then you're going to write the negative 27.15 to negative 12.25. Okay. Now notice this entire interval is negative, and what that means is that, oh, sorry guys. So if we were to draw this picture, we would see that this whole interval spans only negative numbers. And this is really significant because it indicates that no matter what, the first number was less than the second number. So if we go back to the question, the first group was 6th grade and the second was 7th grade. So if one number is less than the other, that means that the 6th grade had less homework than the 7th grade, which should make sense because 6th grade is younger than 7th grade, so they should have less homework. So basically this is proof that the 6th graders do indeed have less homework than the 7th graders. Now, let's do our conclusion sentence and then we'll be done. C for conclusion in context. So you guys remember the formula of the sentence is I am blank % confident, so I'm 95% confident that the true difference of the means is between blank and blank. So make sure that you're using the words difference of the means because it was 2 means this time. I am 95% confident the true difference of the means. Difference of the mean what? Of the mean number of minutes of homework for 6th graders minus 7th graders, because we did 6th graders first, is between blah and blah. And then you put in the blank negative 27.15 minutes and negative 12.25 minutes. So we're pretty confident that indeed the 6th graders have less homework than the 7th. So then how does this connect to a hypothesis test, you ask? Well, let's say they said, is this statistically significant evidence that indeed there is a difference between the mean amount of homework for the 6th and the 7th graders? Well, you know where we're going to move to? We're going to move to 2 means. So HO would be mu1 equals mu2. or mu1 minus mu2 equals 0, meaning there's no difference. And then the HA would be the mu1 is less than mu2, or there is a difference. Basically, 6th graders have less homework than 7th. So if you go back to my picture, is the null of 0 contained in the interval? And the answer is no. 0 is all the way in this tail. So if 0 is in the tail, the P is low. If P is low, reject HO and go with the alternative. So you would say 0 is not possible because 0 is not in the interval. So indeed, this is proof that 6th graders do have less homework than 7th graders.